So on this question, it tells you that you've taken 130 centimeter cube of oxygen and you've taken 40 centimeter cube of nitrogen, and they're both at 298 Kelvin and 100 kPa. So if I pay attention to this data, this is at RTP, room temperature and pressure. And then what you did, you transferred this amount of gases into an evacuated flask of volume this, which is 0.50 dm cube. So I can say in this case I've been given pressure. So my equation is P times V equals N times R times capital T. Based on the information given in the question, this, and this, these all will remain unchanged. They will all remain unchanged. So if they remain unchanged, then I can say that P1 times V1 will be equal to P2 times V2. Are people with me on this bit? This is something that people, especially Ayan and Sarah, because you both do physics as well, you will need to know this. So I can then say I've been given the values of P1, V1, P2 and V2, but only one of these four is unknown, and that is the pressure of gas mixture in flask at 298 Kelvin. Go ahead, Arij.
So what do you mean P1, V1, P2, V2?
Okay, so in this case, I'm saying the product of pressure and volume will be a constant.
So do you mean by P1 the pressure before?
So first, did you understand this part? P times V equals constant. Because so what I'm doing is once they were not, before I added them to the flask, this equation applied to them, and when this equation applies to them, nRT has a value, and once I've transferred them into the flask, the nRT value is still the same, because the number of moles of gas will be still the same. Molar gas constant still has the same value. The temperature also has the same value, because you can see here 298 and 298. So the right side remains unchanged. So I can say there's a link between state 1 and state 2. What is that link? That link is coming from here. PV equals constant. I can say P1 V1 will be equal to P2 V2. Now if I go back to the question, I've been given the P1 value. What is that value given to me as? I can say P1 is 100 kPa times by, what is V1? V1 will be the sum of these two volumes. So 40 add 130 equals, we do not know the value of P2. I'll keep it as P2 times V2 is given to me as 0.50 dm cube. Now I can't use my volume in dm cube, because here, look, the unit must be same on both sides. So this is in kPa, this is in centimeter cube, this should also be in kPa, and this must be in centimeter cube. So how am I going to convert dm cube to centimeter cube? 1 dm cube is 1000. So I can say if I go in this direction, I multiply it by 1000. If I go in this direction, I'll divide it by 1000. So in this case, I'll have to multiply it by 1000. If I multiply 0.5 times by 1000, now there's only one unknown, that is P2. So you just have to work it out. You'll say 100 times 170 equals P2 times 500. You divide both sides by 500. 500. This is gone. You're left with P2 being equal to, how much is it? Will be 34 kPa. So this is something that is important for you to figure out, and this will normally be the case when they will transfer gas from one location to another. Okay, are we happy? Now this was one of the questions that I wanted to do in the first place. Now we'll go back at the start of the paper and then we'll carry on from there. Going back to question number 1. It says on this question that you've been given anhydrous magnesium chloride, which is MgCl2. Anhydrous means it does not have water of crystallization. It can absorb water to form hydrated salt. Hydrated means it now contains water of crystallization. So MgCl2, add water, and it changes into MgCl2 4H2O. It says suggest one reason why the enthalpy change of this reaction cannot be determined directly by calorimetry. Now, if you look at it at start, your reactant was solid, your product is solid. How will you work out the change in temperature that will take place for the solid? It is very difficult. So we can say delta T for solid is hard to measure. Okay. Now on the next part, what are they saying? They've given us again two enthalpies, and these are both enthalpy changes of solution. So if I pick up my original equation at the top, my original equation was MgCl2 solid plus 4H2O liquid. It gave me MgCl2 dot 4H2O solid. It is possible to convert my reactants into a solution. It is possible to convert my product into a solution. And regardless of whether I take the left side or the right side, I'll end up with the same product. So I can say, if I add it into a solution, it will change into if I add this into water, it will change into MgCl2 aqueous, and this will also change into MgCl2 aqueous. Now if I look at this table, they've given us some values. I can change MgCl2 into MgCl2 aqueous, and it will release minus 155 kilojoules of energy. So this is minus 155. When I change this into solution, it will release minus 39 kilojoules of energy. This is something that is not known, and this is what the question says. It says calculate the enthalpy change for the absorption of water by MgCl2 to form Mg4H2. Okay, MgCl2 4H2O, which is hydrated. So I can say direct route is always equal to indirect. So the direct route in this case is this one. So I'll say minus 155 will now be equal to delta HR plus and minus 30. So it becomes minus 155 equals delta HR minus 39. You do plus 39 on both sides. This is gone. You are left with delta HR being equal to something, and that is your answer. Okay. Any questions so far? No question. That means I'll just take as everyone has understood everything so far. Done? Okay. Now in your exam, there will be questions like these as well. Who knows? There might be a question on determining the enthalpy change of solution. So you make sure you know the process here. Right? It says describe how you would carry out an experiment to determine the enthalpy of solution of anhydrous magnesium chloride. So whenever we have to work out the enthalpy, there are two steps involved. What are those two steps? We do delta Q equals M times C times delta T. And then we do delta H is equal to delta Q over moles. Are we happy with that bit? Now, if you remember this bit, then the rest is all easy. What are the measurements that we have to make? And we have to ensure, okay, less heat losses in the experiment. So we have to ensure less heat losses will take place while we do this experiment, because we are assuming that all energy that is released from the reaction will stay in water. So in the first step, I can say I have to use a cup. What kind of cup am I going to use in this case? I'm not going to use beaker, because if I use beaker, it will give me more error because it will absorb a lot of energy. So I can say can use polyester cup, and we can say with lid. Okay, number 2, what are we going to do? We need to work out the mass of anhydrous magnesium chloride that we will use, because it says explain how your results could be used to calculate the enthalpy of solution. So let's say here, I can say record mass of empty cup. Number 2, I can say, number 3, I can then say add MgCl2 solid and record new mass. Okay. Yes, Arij, go ahead.
So how have they already told us that it's 0.8 grams though?
No, but in this case, we have to make sure that we are going to be using the accurate mass. It says use about.
I don't get it. So how would you know it's accurate?
So use about means what? How will you know that you have used 0.8? Can you make sure that it is 0.8?
Oh, so you talk about how you measure 0.8.
We don't have to. It says about. About means it can go up and down. Little bit up, little bit down. That's fine. And that's what we are doing, because we need to know exact masses, exact mass of the MgCl2 used, because these are the moles of MgCl2.
Okay, I got it.
Okay, then now so far I can then say mass of MgCl2 used will be equal to 3 take away 2. Then I can say number 4, I'll say add, let's say 50 centimeter cube of, all I do, water. Can I say that? Add 50 centimeter cube of water into now I think I've gone a little bit wrong here. Where did I go wrong? I think I should have added this mass later on. Okay, so what we can do in this case is that's fine. So what we are doing is fine as well. You can say add 50 centimeter cube of H2O using measuring cylinder to the, what is it, polystyrene cup. Is that the right spelling for polystyrene? TY. So that was right then. RENE. I think so. We've made small mistake somewhere. And what is that small mistake? Let's fix it before we go ahead. So this is fine. Add 50 centimeter cube of H2O into measuring cylinder using measuring cylinder to the polystyrene cup. That's fine. We can then say record its mass. Are we happy for that? Now, what I want to do here is, that's fine. Next bit that I'm going to do is number 5. I'm going to say you will record temperature of water at 1 minute interval. Are we happy with that bit? Number 6, I'll say on 5th minute, all I do, I'll add MgCl2 and record temperature. All I do, record temperature at an interval of 1 minute for next, say 10 minutes. We can say 5 minutes is enough. Can we cross bullet point number 2 and 3? So far I said you'll use polystyrene cup with lid. We'll add 50 centimeter cube of water using measuring cylinder to the polystyrene cup. We'll record its mass. Record temperature of water at 1 minute interval. On the 5th minute, add MgCl2 and record temperature at interval of 1 minute for next 5 minutes. Okay. Add one more word here. Until T equals 4 minutes. Now on the 5th minute, we are not recording any data. Then what do I do? Number 7, I can say you will record mass of cup with its content. Now I can then say number 8, mass of MgCl2 solid used will be equal to 7 take away 4. Are people with me on this bit? Because on 7, what is it? I've got everything in the polystyrene cup. Here I recorded the mass of polystyrene cup and water. So if I take away mass of polystyrene cup and water away from the entire content, that will give me the mass of MgCl2 used. Once I'm done with this, then I will plot the graph of temperature against time. I'll have two lines. I'll have line here, I'll have line here. Okay, I'll have a line here and I'll have a line here. Now what I will do is, in this case, is I will then extend this line to the top, because this is when I added, I can say this is when MgCl2 is added. I can then extrapolate this line backwards and I can say this will be my delta T. Are people with me on this, what I just said? This will be my delta T. So now I know the values here. I can then say step number 10 will be, I'll write down Q equals M times C times delta T. This will be 25, because I used the volume of water was 25, times by C times by delta T, which will come from here. Once I know this, then I'll do point number 11 will be delta H will be equal to Q divided by moles of MgCl. Has anyone got any questions so far? Sama, all good? People taking class online, are we all connected? Has anyone got any question? If not, then I want to move on. Now the next part of this question says, anhydrous magnesium chloride can be formed by direct reaction between its elements. This is my enthalpy change of formation. The free energy change delta G for this reaction varies with temperature as shown in table. They've given us the temperature here, they've given us the delta G values here. So you recall there's an equation, delta G equals delta H minus T delta S. Says use these data to plot a graph of free energy change diagram against free energy change against temperature on the right, on the grid opposite. You have to plot this data on this side of the page. It says calculate the gradient of the line of your graph and hence calculate the entropy change in joules per Kelvin mole per mole for the formation of anhydrous magnesium chloride from its elements. Now they've spoken something about the gradient. So if I look at this, what am I doing? I'm going to plot delta G on y-axis, and I'm going to plot the temperature on x-axis. So if I rearrange this equation changes. Delta G equals minus T delta S plus delta H. So if I write it down, this is same as okay. I'm going to rewrite it once more. Delta G equals minus delta S T plus delta H. And if you compare it, it is same as y equals mx plus c. And in this case, minus T delta S is my gradient. Okay, so basically my gradient will be equal to minus delta S. So whatever the gradient is for this graph, that will be your minus delta S value. But remember, when you work out the gradient, our gradient will come out in kilojoules per mole over Kelvin. So the gradient value, I'm just going to make a note here, will require unit conversion. Require unit conversion. Now, luckily this time what they have done is they've already given you the scale on the y-axis and on x-axis. Both the scales have been given to you. So if you plot this graph, it will be a straight line. It will be a straight line graph. And if you calculate the gradient of that graph, I can pick it up the value from mark scheme. Let me see what is the value of the gradient. 1 second. So the gradient value for this turns out to be equal to 0.167. It will be kilojoules per mole and Kelvin. So I'll have to change this into joules, which is 0.167 times by 1000. I will change it to minus 1. Now remember, this is my gradient, so this will be equal to minus delta S. So minus delta S will be 167 joules per mole Kelvin. But I can then divide, there's a 1 here, I can divide both sides by minus 1. It will become delta S will be minus 167 joules per mole Kelvin. Done. So that was all about question 1. Let's move on to question number 2. Now here it says sulfuric acid reacts with alkenes, alcohols, and sodium halides. There are 3 compounds with which sulfuric acid reacts. Name the mechanism for the reaction of concentrated sulfuric acid with an alkene. Now we know alkenes, they have a double bond. And this is electron rich region. So it will accept electrophiles. So it will be electrophilic addition reaction. And say it will be electrophilic addition. It says outline the mechanism of reaction of concentrated sulfuric acid with propene to show the formation of major product. So the major product will be the one that will involve more stable carbocation. So we've got propene. I can say 1, 2, 3. I've got this. I can then draw some 1, 2, 3, 1, 2, 3. What will happen in this case is for sulfuric acid, I can say it is S double bond O, S double bond O dash O. H. Here you have O, here you have H. And then say the lone pair from here will be given to this. This will give its electrons to oxygen. This will be delta plus, this will be delta minus. As a result of this, now we need to form 1, 2, 3. Which one will be more stable carbocation? Is it here or is it going to be here? So if I put plus here and hydrogen here, that will be my, what kind of carbocation? Secondary, no, primary, because it will have 2 hydrogens. If I put my positive here and if I attach hydrogen here, then it will become a secondary carbocation. So I'm going to say I'll have a hydrogen here and I'll have positive. Okay, so I can say this is my secondary carbocation. Now this section, here, and as a result of this, it will then change into 1, 2, 3. O dash S double bond O double bond O and OH. Those are all hydrogens around it. Now the next part says draw the structure of the minor product. Minor product will be my this carbocation, because it will be primary carbocation, so it will be C1, 2, 1, 2. It will be O dash S double bond O and OH. In this case, this will be my primary carbocation. Now see, because I've been annotating as I was doing this question, the next part talks about what I just wrote here. It will involve more stable carbocation. It says explain why the product shown in your answer to question 2.2 is major product. So I just have to say because it involves secondary carbocation. Number 1, it does say explain, so I have to give reason. Why is it that secondary carbocation are more stable? So I'll say secondary carbocation are more stable. Why are they more stable? Due to greater inductive effect of alkyl groups. Next section here, question 2.5. It talks about butane 2O reacts with concentrated sulfuric acid to form a mixture of 3 isomeric alkenes. 2 of the alkenes are stereoisomers. Draw the skeletal formula for each of the 3 isomeric alkenes formed by the reaction of butane 2O with concentrated sulfuric acid. So the moment I see this butane 2O, I'm going to draw its structure. How many carbons are there? 1, 2, 3, 4. On the second carbon atom, I have OH. Now there are 2 possibilities. I can remove this due to elimination reaction, or I can remove this section. If I remove the blue section, then the double bond will appear there. If I remove the green section, then the double bond will appear here. Now if you look at the green one, I can have, for the green one, I can have E and Z. But for the blue one, I can't have E and Z. So let's start with the blue one first. And if I draw the blue one here, it will be C H H double bond C H and CH3. They've asked us for skeletal formula. I can't leave this like that. I have to draw the skeletal formula. I've made a small mistake again. It should be C2H5. So when I draw the skeletal formula, I'll have 1, 2, 3, 1, 2, 3, 4 carbons. And on the first between the first and the second carbon, there's a double bond. Okay, what will be the name of this one? This will be but1ene. Now, if I look at the green one, then I'll have C double bond C. Okay, let's draw it in green. Here I'll have H. Here I'll have CH3. Here I'll have CH3. Here I'll have H. And I can now see if I flip this side, then it will become another product, which will be the stereoisomer. You can have H, CH3. You can have H, and I can have CH3. So if I draw the skeletal formula for them again, for this one, I can say 1, 2, 1, 2, 3, 4. That. Agreed. What will be the name for this one? In this case, they are in diagonal. So the high priority groups are across. So I can say this will be my E-but2ene. If I draw the structure of this one, it will be this, this, and that. I have a double bond here. And this one will be Z-but2. Okay. Why is this E? Because high priority are across. Here, high priority are on same side. Next question. Says byproduct of the reaction of butane 2-ol. Yes, Arij.
So are you recording this lesson today?
Yes, I am.
Okay, that's fine. Because I couldn't see the red thing. Okay, that's fine. Thank you.
This question, it says a byproduct of the reaction of butane 2-ol with concentrated sulfuric acid has a molecular formula of C4H8O. C4H8O. It has only one oxygen now. How many oxygens does it have in the first place? It has one oxygen. But what has happened now, if I look at butane 2-ol, it was 1, 2, 3, 4. 1, 2, 3, 1, 2, 1, 2, 3. Here you have. How many hydrogens are there, Simon? This is C4. H8. No. C4H10O. Now it has become C4H8O. C4H8O. Says name this product, identify role of sulfuric acid in the formation, and suggest the name of method that could be used to separate the product of this reaction. Now in this case, you know these are alcohols and they can be oxidized. So this is my secondary alcohol. If it is secondary alcohol, if it oxidizes, it will change into a ketone. It will change into a ketone. So I can say the byproduct will be CH3, C double bond O dash C2H5. The role of sulfuric acid in this case is oxidizing agent. So now I've got two things together. I've got alcohol plus ketone. Okay. Plus, what else do I have? We've got alkene as well. Because on the previous page, what is happening when you make it react with sulfuric acid, it does produce alkene. Now we need to separate them. How do we separate them? I've got more than one liquid. I will make use of fractional distillation. Now the next question is about reaction of sulfuric acids with group 7 elements, right? Or group 7 ions, halide ions. It says concentrated sulfuric acid reacts with solid sodium chloride. Give the observation you would make in this reaction. State the role of sulfuric acid. We know in this case, if you recall from your notes, you will notice or you'll figure out so when you make it react with sodium chloride, what will happen in this case? It will produce salt of sulfuric acid rather than salt of hydrochloric acid. So observations will be I would say the hydrochloric acid will get regenerated. So if it gets regenerated, you would say white fumes of HCl. What is the role of sulfuric acid in this case? The role of sulfuric acid in this case will be acting as acid, or you can say it is proton donor. Now if I just leave it like this, I know you guys will struggle, so let's quickly write down the equation for this. So what is happening in this case is we have H2SO4, we reacted with NaCl, it will produce Na2SO4 plus HCl. Now I'm not balancing this equation, but this is an acid-base reaction. Okay, not a redox reaction. Next part says concentrated sulfuric acid reacts with solid sodium iodide. So iodide ions to produce several products. Observations made during this reaction include the formation of black solid, yellow solid, and a gas with smell of bad eggs. So if you recall, in this case, we said the black solid will be I2. It will be I2. What will be the yellow solid? It will be sulfur, which is S8, and the gas will be H2S. Okay, these are three redox reactions that happen with iodide. Okay, so what I'm trying to say here is, let me quickly show it to you so that it makes a bit more sense to people. I will share this file with you people at some point. Can people see my screen now? So if you look at it, yeah. I will share this file. I'll send it to you guys. It's something which is important for us to know. You can see here, in case of NaCl, will only produce one product, which is HCl. With NaBr, it will produce three products, HBr, Br2, and SO2. With iodide ions, it will produce four products, or not four, five. HI, I2, so the first one is acid base. Second, third, fourth, and fifth reaction, these are all redox reactions. Okay, I'll share this with you people, and you just keep it safe. So it kind of summarizes everything for you that you need to know for topic halogens. So let's move on to question number 3. It says benzoic acid can be prepared from the ethyl benzoate. So this is my ester. It says ethyl benzoate is first hydrolyzed in alkaline conditions as shown. So this is the salt of carboxylic acid and produces alcohol. It says a student used the following method. Add 5 centimeter cube of ethyl benzoate. Density is 1.05 grams per centimeter cube. Now if you look at this information, this is important. who knows, something similar might turn up in your exam. So when they give you the volume and density, it can be used to work out the mass. You can work out the mass from density and volume. And then you know the mass, you've been given the MR. If you divide mass by MR, you'll be able to work out the moles as well. So I can highlight the remaining section here as well. I can say I can work out the mass, and I can then work out the moles as well from here. Says to 30 centimeter cube of aqueous 2 mole per dm cube sodium hydroxide in a round bottom flask. So you've added this mixture together, and they've given you some quantities here. Says add a few anti-bumping granules and attach a condenser to the flask. Heat the mixture under reflux for half an hour. Allow the mixture to cool to room temperature. Then you've added 50 centimeter cube of 2 mole dm cube hydrochloric acid into the cool mixture. Why are we adding this? So that we can neutralize the excess amount of sodium hydroxide. Says filter off the precipitate of benzoic acid under reduced pressure. Suggest how the anti-bumping granules prevent bumping during reflux. So anti-bumping granules, what they do is they provide you with larger surface area. So provide larger surface area for bubbles to form. Next part says show by calculation then that an excess of sodium hydroxide is used in this reaction. So first of all, I've been given here the volume of sodium hydroxide and the concentration. So I can work out the moles. So I can say moles of NaOH will be equal to 2 times 30 over 1,000. And this gives me an answer which will be equal to 0.06 moles. Now my equation says that the ester ratio alkali is 1 to 1. That's what my equation says. 1 mole of ester will react with 1 mole of NaOH to produce the desired products. So let's see how many moles of ester do we have. For that, step 2 will be to find the moles of ester, and I told you how you can work them out. So you have to use the formula for density. So I can say density equals mass over volume. I've been given density as 1.05 equals mass over volume is 5. From here, the mass turns out to be 5.25 grams. Then I can work out the moles, which will be 5.25 divided by the MR, which is 150, and it gives me answer as 0.035. So I need only 0.035 moles of NaOH, but I have 0.06 moles. So the moles required for NaOH are equal to 0.035, whereas available are moles equals 0.06, therefore in excess. Go ahead, Arish.
So what is this NV?
Where is NV?
No, you know the step number 2.
Yeah, this is density equals mass over volume. That's the equation you have to remember.
So why have you written D like that?
Where did I write D? This is not D. This is the symbol for density. That's called that's called rho.
Oh, sorry.
Okay.
Thank you.
No, that's fine. Okay, so this can be written like that too. Any questions so far? Okay. Now the next part here says suggest why excess sodium hydroxide is used. Now it's just a matter of understanding. If I do not use the required amount of NaOH, will all of my ester change in my desired products? No. So this is to ensure that all of the ester gets hydrolyzed. So we can say to ensure ester is completely hydrolyzed. Next part says why an electric heater is used rather than a Bunsen burner in this hydrolysis. So in this case, you have already seen the product in this case is, if I show it to you, how many carbons do I have in this case? This is my ethanol. So ethanol is flammable, so we can say ethanol and ester are flammable. So they'll catch fire. State why reflux is used in this hydrolysis, because we do not want any of our reactants or products to escape. It doesn't allow any reactant vapor to escape. Please write an equation for the reaction between sodium benzoate and hydrochloric acid. Now, sodium benzoate, this is basically salt of weak acid. We know if you add strong acid to salt of weak acid, then it will form salt of strong acid and the weak acid will get recovered. So I can write down sodium benzoate is C6H5COONA plus HCl. It will form C6H5COOH plus NaCl. Next part says suggest why sodium benzoate is soluble in cold water. Now, what is sodium benzoate? It is ionic salt. And ionic substances are soluble in water. Whereas benzoic acid is insoluble. This is insoluble because we can say there are two sections to it. One is the COOH section can form H bonds, whereas the ring is non-polar. So if it is non-polar, ring is the one which is restricting its solubility. Done. Okay. Next question here says, after the solid benzoic acid has been filtered off, it can be purified. What does this mean? This means it still has got some impurities in it. Describe the method that the student should use to purify the benzoic acid. So we are assuming in this case the has insoluble impurities. This is what our assumption is. We are assuming it has insoluble impurities. So what I can say is we've already seen before that benzoic acid is not soluble in cold water. So which type of water will I need to dissolve it in? So I'll have to say I'll dissolve acid in hot water. We have to say hot water. Okay, number one. Number two, I'll say use minimum volume. Volume of H2O. Then what will I do? Now I'll have two kind of things in my solution. Dissolved acid and insoluble solid impurities. I can then say filter to remove insoluble solids. What will I then do? Now it is hot water. So if I change it to cold water, what will happen? It will become solid, right? So I can say let solution cool We are not evaporating it like we do in case of salts. In this case, what are we doing? We are letting it cool down. So if it cools down, what will happen in this case? I can say acid will solidify. What will I then do? Then I'll have to filter under reduced pressure. Filter under reduced pressure. So this is similar to what you do when you are doing synthesis of aspirin in an experiment, that you make the aspirin. Next one, what do I do now? Filter under reduced pressure. I can wash with cold water, and then you will draw. Wash with cold solvent and dry. Done. Next question. Now this is the last structured question, and after that all are multiple choice questions. So still there is one more part before we can get to the final question. Here it says, in a similar experiment, another student used 0.040 moles of ethyl benzoate and obtained 5.12 grams of benzoic acid. Calculate the percentage yield of benzoic acid. Percentage yield. How do you work out the percentage yield? This is experimental over theoretical times by 100. So we already know this value experimental. It is given to us in the question, which is 5.12. We now have to go back to the equation, and we can see on the equation it says if you use 1 mole of this, then technically speaking it should produce 1 mole of benzoic acid. It should produce 1 mole of benzoic acid if the yield is 100%. So I can then say, what is the MR for ester? Okay, before we don't even need to know the MR of ester because they've told us 0.4 moles of ester. So I can say ester to acid. The mole ratio is 1 to 1. Agreed. How many moles did I use? In my case, it is 0.04. They'll also produce 0.04 moles of acid. Yes, Arij.
So are you writing anything? Because we can't really see.
You can't see anything.
It's frozen, so I think. It's just the question.
Hang on. So I can now say, because we are using this many moles of ester, this many moles of acid should be produced. Okay. Now, I need mass in this equation. So to convert this into mass, I'll have to multiply it by mR. And if I do that, I will end up with a value of 4.88 grams. I'll end up with 4.88 grams. I can give you a bit of more help here. The MR of benzoic acid is 122. Okay, now if I plug these values in, I'll end up with 4.88 divided by what's the value of theoretical? Should be 5.12 because that's experimental, divided by 4.88 times by 100. And if you do that, you'll end up with 105%. Now it's clearly impossible thing to happen. The maximum thing that you can get is 100%, and that's not even possible, right? Because there's always some waste product. It just gets wasted. So while you're washing the benzoic acid, some of it will get wasted. So it clearly tells me in this student's case, this 105% is telling me that there are a lot of impurities in his benzoic acid. So we can say it is, I can say suggestion is impurities present. Done. Let's move on to the next question. On this question, it says, now this is about acid-base titrations. So what is happening here? It says you've been given this many mole dm cube solution of sodium hydroxide, and it was gradually added to 25 centimeter cube of solution of weak acid. So acid is how much? 25 centimeter cube. How much alkali do I have? We don't know that bit, but I can work out the amount of alkali that was required for the neutralization. So alkali is 0.100 mole per dm cube, and the volume will be, how much is it? From here I can work out about 24 centimeter cube. Are we happy with this bit so far? So I know the data for my alkali. I can use this data to work out the moles of alkali used, and so on. So let's see what the question says. The question says it's a weak acid HX, and it is monoprotic. That means it can only release one hydrogen ion. In the presence of suitable indicator, a graph was plotted of pH against the volume of sodium hydroxide solution as shown in figure 1. The first pH reading was taken after 20 centimeter cube of a solution of sodium hydroxide solution had been added. The acid dissociation constant of HX is equal to 2.62 times 10 to the power of minus 5. Something useful again. In this case, I can say this means 2.62 times 10 to the power of minus 5 will be equal to H positive X minus over HX. Okay. Now the next part says the pH range of an indicator is the range over which it changes color. Suggest the pH range of a suitable indicator for this titration. So we need to know. So if you recall from your previous understanding, the pH should change color in the vertical section. So what is the pH value that my indicator can have for this vertical section? So I can go for this section, and if you pay attention to this, you will notice this is value between 7 and 10.2. So here it is 7, here it is 10.2. Okay. Now next one says give the expression for the acid dissociation constant. You see, I was annotating at the start, so I was able to relate something. So I can copy it down here, and I can say it will be H positive times X negative over HX concentration. If I turn it over to the next page, it says calculate the concentration of HX, the original solution. In the original solution for HX. So I wrote some data here. If you look, I wrote the data for the alkali, and I wrote the data for the acid, and I know my acid can only release one hydrogen ion. My base can also accept one hydrogen ion. So in other words, I can say the moles of alkali will be same as the moles of acid. So first I'll work out the moles of alkali, then that will be equal to the moles of acid, and from there plus this volume can be used to work out the concentration of original acid. So I'll do first thing, moles of NaOH. These will be 24 times 0.1 over 1,000, and it turns out to be 2.4 times 10 to the power of minus 3. Okay, we can write down 2.40. Next one, I can then say moles of acid will also be 2.40 times 10 to the power of minus 3. Then I can work out concentration of acid can be worked out using moles equals C times V over 1,000. You can change moles with 2.40 times 10 to the power of minus 3 equals C times the volume of acid was how much? 25 over 1000. And from here, your concentration value will change to 0.0960 mole per dm cube. Now the next part says calculate the pH of the solution of HX before the addition of any sodium hydroxide, before the addition of any. So this means I'm going to use Ka equals H positive X minus over Hx, and I'm going to say H positive concentration will be same as X minus, and therefore I can say it will be Ka times Hx square root will give me the concentration of H positive. All I have to do is just put the values in. We know the value of Ka given to us in the question is 2.62 times 10 to the power of minus 5 times by the concentration was worked out on the previous question, which is 0.0960. You take square root of this and it will give you the value of concentration for H plus points. Once I know the concentration, I'll have to plug this value in. pH equals minus log of 10H plus. Does that make sense? And it will give you the value of pH, which in this case is 2.80. Now the next question says calculate the pH of the solution when half of the acid has reacted. Half of the acid has reacted. This means they are talking about pH at half neutralization point. When this is the case, then pKa is same as pH. So if you do that, you will end up with pH being equal to minus log 10 Ka, and the value of Ka is already known. From there, you will end up with the value of pH being 4.58. It is a bit hard question, but you have to make sure you look at it right before you go for exam. I'm not sure, was there any question like this on paper 1 with acid titrations? But what, so who knows, there could be some, whatever it was, right? But this is just one of the questions, which is really good question to understand how you're going to assess the situation related to titrations. Now we need to complete. It says plot your answers to question 4.4 and plot your answers to question 4.4 and 4.5 on the grid in figure 1. Figure 1 is, if I go backwards, this is half neutralization point, which is 4.58. Half neutralization point will be when half of this solution has been used. So half of this solution means when I have used 12 centimeter cube of my alkali. So this is 12 centimeter cube. The value of my pH is 4.58, which is probably 4.6. So 12 and 4.6, 4.4, 4.2, 4.4, 4.6, and this is 11, this is 12. That's 1. Okay, the next one will be, what was the original, when this is the pH of HX. This means nothing has been added to the acid yet. So when no volume of NaOH was added, it was 2.80. 2.80 is over here, and you just have to complete the graph. So it will be like that. One of the good questions. Yeah, it is a very good question. So make sure you revise before you go for the exam. Now let's quickly have a look at some of the multiple choice questions on this paper. Some of them were very, very easy when I was preparing for you people. Some of them do require calculations. So my recommendation to all of you is, because it's our last lesson today, I won't have you again. I just want to remind you, always any question which is multiple choice question requires you to perform calculations. Do that question towards the end of your exam. Don't spend time on that question because it's only 1 mark. You can leave that question, and if there is time, you can come back. Okay, so don't spend time on that. Here it says, which compound has the highest melting point? Now you need to recode. Melting point will depend, and if you look at these are all organic molecules. So if they are all organic molecules, that means they will all have intermolecular forces of attraction. So I can clearly see the first one is alcohol. It will have H bonding. This is aldehyde. This one doesn't have H bonding. It will be dipole, dipole. This one is ketone. Again, dipole, dipole. This one is ester. Again, dipole, dipole. There's only one that has hydrogen bonding, so my answer will be A. Okay, remember, the main thing that you have to remember is they are all organic molecules. Go ahead, reach.
So do we not have a lesson next week?
No, we don't have a lesson next week. This is our last lesson.
Why don't we have a lesson next week?
We don't. We can do before Saturday then, if you guys want to take one. Chalo, we'll discuss that towards the end, inshallah. Okay.
Okay.
All are organic molecules, so IMF is something that you need to consider. Now the next question is about which is the correct order of melting points of these period 3 elements. So when it comes to period 3 elements, you can see group 1, group 2, group 3. They are all 1, 2, 3. They are metallic. Okay. 4, 1 is giant covalent. Then 5 is phosphorus, which is P4. Then you have S8. Okay, happy? So in this case, I can see here sulfur will have a higher boiling, is it melting point? Yes, melting point than phosphorus. Why? Because it's a bigger molecule, it has more electrons in it. So when I look at the first option, this section is wrong. When I look at the second section, that's different, but this is correct order for me to consider. Because this is S8, this is P4, this is Cl2, and this is just AR. Greatest number of electrons, next, second greatest number of electrons, third, and then no. So in this case, strongest intermolecular force of attraction. Here, weakest intermolecular forces of attraction. The answer will be C. Now the next question here is about, it says which statement is not a correct statement. So you have to focus on these kind of words. It says transition metals form colored ions and complexes. That's true. It says transition metals display variable oxidation states. That's true as well. It says a ligand accepts a pair of electrons. Does it accept? This is wrong. The job of the ligand is to form a dative covalent bond by donating a pair of electrons. So the answer is C. Question 8. The table shows possible conditions and products for cracking of alkane. I want you to put star on this question because it's an important question. Make sure you revise this question before you go for your exam. Now for the thermal cracking, the condition that we use is 70 atm and about 750 degrees Celsius temperature. For the catalytic cracking, we use temperature of 550 degrees Celsius and we use low pressure. So if I look at this section, this is correct, but this is wrong. Mainly alkanes. It does produce alkenes too. In the second case, this section is wrong. And this is also wrong, right? It doesn't produce only alkenes. In case of catalytic cracking, you use slight high pressure. This is right. High temperature, that's fine. and it will produce these products too. In this case, this is wrong here. This is right, and this one is correct. So make sure you revise this question before you go for the exam, because who knows, they may give you a question. A student wants, our desire is to produce branched alkanes and aromatic compounds. Should we go for thermal or catalytic cracking? Then the next question might be, what are the conditions used for the catalytic cracking? Then you'll have to read for this bit. It could be 2 marks in your exam. Next question talks about 2,4,6 trichlorophenol is a weak monoprotic acid with Ka value as this at 298 Kelvin. What is the concentration in mole per dm cube of hydrogen ions in a 2 mole per dm cube solution of 2,4,6 trichlorophenol at 298? So concentration of hydrogen ions, it can be worked out in 2 ways. One is using pH, but we haven't got a value of pH. We've been given that it is a weak monoprotic acid, so I can say Ka will be equal to H plus squared over Hx. And if you plug the values in and you solve, you'll end up with the value of concentration of H being B. So all you have to do is you just plug in the values. You've been given the concentration here. This value will go in here. This value will go here. And if you solve this, you'll just work out the answer. And the answer will be 7.09 times 10 to the power of minus 6. Question number 10 says, what is the pH of 0.46 mole dm cube solution of potassium hydroxide? Now they're talking about pH of alkaline solution. So you have to remember, for the pH of alkaline solution, we always go for the ionic product of water. So you'll have to do Kw equals H positive and OH minus. So we know the value of Kw. This value will be substituted there. We know the value of OH will be, this value will be substituted here. And from here, you will work out the value of H positive. Once you know the value of H positive, from here, you can then work out the value of pH. Okay, so 3 steps. The main thing that you have to remember is, whenever it is alkaline solution and they ask you to work out the pH, you'll always use the ionic product of water. The concentration of OH ions will come from the alkaline solution. Concentration Kw is a constant, which is known, given to you. From here, you can then, if you make H positive your subject, that will be a concentration of H plus. Once you know the concentration of H plus, you can use pH equals minus log 10 H positive, and will give you the answer. So if you work out, the answer will turn out to be 13.66. So there's a very good chance, if you have less time and you want to choose an answer for this, don't just openly say A, B, let's go for B, let's go for C. No, this is for acid. You can't have a pH value above 14.34. So you now have 50% chance of getting it right and wrong. So you can say this is a reasonable one. Why? Because it is solution. It is not pure. So you can go for 13.66. Next question says, what is the mass in milligrams of carbon formed when 3.0 times 10 to the power of minus 3 mole of propene undergoes incomplete combustion? So they've given us the equation. So 2 moles will produce 6 moles. So the ratio is 1 to 3. The ratio is 1 to 3. So if you burn this many moles of propene, the moles of carbon dioxide produced will be, say, moles of carbon monoxide will be 3 times 3.0 times 10 to the power of minus 3, which is 9 times 10 to the power of minus 3. These are my moles. Now to convert moles into mass, what will I do? I can multiply it by 12, which is my AR, and will give me an answer. One second, and I'll take your question then. It will give me answer 0.9 times 10 to the power of minus 3 times by 12. That gives me answer as 0.108. Remember, this will be in grams. Now from grams to milligrams. What do? You'll multiply it by 1000. From here to here, you'll divide by 1000. So you'll multiply it. In this case, you'll multiply it by 1000. It will be 108 milligrams. So the answer will be, now 108. Which one is same? If you look at them two, if you multiply it by 10 to the power of 2, they both are the same answer. This is same as 108. So the answer is C. Now go ahead and read.
So why have you written moles of CO? There's no CO in the question.
That's fine. These are moles of carbon. Thank you. That's fine. Thank you. But I did use the correct AR here, right?
Yeah, thank you.
That's fine. No worries. Thank you. Next question. Now there's a peak here. This peak is always for this. This peak is for the carbonyl compound. Now, do I have a carbonyl compound in this one? No. Do I have a carbonyl compound here? No. Do I have carbonyl compound here? Possibly yes, in butanoic acid. But for a butanoic acid, this will be a little bit more bigger. Okay, so in this case, the only option that is true is C. Next question talks about which pair of compound does not form a racemic mixture. Does not form racemic mixture. This means 50% of each enantiomer. Okay, so does not produce 50% of each enantiomer. So I can say this, what I just said here, this means this. Okay, so they are saying it does not produce 50% of each enantiomer. So if I look at this and if I add hydrogen chloride to this molecule on the left side, there are 4 carbons, 1 2 3 4. Between second and third there's a double bond. So if I add HCl, there's possibility I'll have hydrogen here and Cl here. And there will be only one product in this case. You can't have 2 products. So if I look at it, this one is chiral carbon. This one is chiral carbon. And then I have a double bond here. So it's a planar structure. So if it is a planar structure, that means there's 50% chance of HCl attacking from above and 50% chance of it attacking from the below. So this one will produce racemic. That's fine. In this case also it will produce racemic mixture because it's again planar. Plus once you have, look what is happening here, I can say 1 2 1 2 3 and 4, 1 2 3 double bond O dash H. What will happen to this? You are adding HCN. This will change to H, this will change to C, and this is again my chiral carbon. So if there's a chiral carbon, this will also produce racemic mixture. In this case, I've got an alkene again. What is going to happen in this case? Again, we can have a look. This is A, this is B. I can draw the C, which is 1 2 3 4 carbons. Once I've got 4 carbons, I'm adding HCl. Now, in this case, there are 2 possibilities. I can have H here and Cl here. I can have H here and I can have Cl here. If I look at it, this is not my chiral carbon. If I have H here, then this does make this carbon act in chiral carbon. And because it's a planar structure at this location, it will have 50% chance of attack from the above, 50% chance of attack from below. So again, I can say C will produce that too. But if I look at this, this is symmetrical. So in this case, what will happen when you add this? It will change into CH3-C-OH, Cn and CH3. So in this case, I can say there is no chiral carbon. Therefore, the answer is D. It can't even produce the, I can say the optical isomers. They will not exist in case of D. Are we happy with that bit? Okay. Again, an important question from your exam point of view. Now, the next question talks about some route for synthesis of a desired product. So you've been given an alkane. Then you do free radical substitution reaction. I can write down free radical substitution. Then you've got haloalkane, and in this haloalkane you are doing you are adding NaOH, and it forms an alcohol. So we know OH in this case will be my nucleophile. So this will be nucleophilic substitution. Then step C, double bond has been introduced. This is my elimination. And for step D, this will be addition. It will be electrophilic addition. Now it says which step occurs by nucleophilic substitution. So I've already worked out the answer because I've already annotated on the diagram. So the answer is B. I'm going to skip question 15 for now because I never had time to look into the book for this question. So, but the answer is B, okay? I'm just giving you the answer for this question. The answer for this question is B. Next question here. This is about Boltzmann distribution diagram. So it says the diagram shows the Maxwell-Boltzmann distribution of molecular energies in a gas at two different temperatures. So I can clearly see here, if I say, let's say I'm just making it up, this is my EA. At what temperature do I have? Which curve has more particles with energy greater than EA? So this will be, I can say this is T1, this is T2. So I'm going to say T1 is greater than T2. Why? Because there are more particles on the right side of this line for the graph for T1. It says which letter represents the most portable energy of the molecules at the higher temperature? Most probable energy. Which one is the most probable energy at higher temperature? So I've already worked out this is my T1, which is higher. Most probable energy is the energy that is carried by biggest fraction of molecules. So in this case, I'll say it will be D. The answer will be D. So we can say these are, both of these are most probable energies. Okay. Now for question number 17, you have to memorize the steps because I gave you two reactions in transition elements for catalysis. One of them is the contact process and the other one is, I think, is it about iodine? One of the reaction is about that and the other one is about iodine. Sulfur dioxide and iodine. Okay. Notes from yes, the other one is sulfur dioxide. It's not sulfur dioxide, it's S2O8 reacting with iodine. Okay, so that's what you have to remember. Now in this case, when it is about the contact process, there are two equations in out of these four. There are only two equations which are valid for the contact process. The two equations in this case are, this is my step 1 of contact process and this is my step 2 of contact process. So I'll again ask you to put star on this question and make sure you go through it. Now if I look at the, so I'm now going to look at B and D because those are not the two steps of contact process. So in the first case, I can see here vanadium is oxidized. So vanadium here is +5, here it is +4. So this is reduced. If I look at the C section, option C, here it is +4 and here it is +5. So it has been oxidized. And I can also see here because it has gained another oxygen. So the answer in this case will be C. Now next question, you will have to choose one of these which will give you this as the outcome. So here it says this structure shows a section of a polymer chain formed by the random polymerization. Random polymerization means this is not something that will happen in order. So just two molecules with double bond came next to each other, they changed into an unsaturated hydrocarbon. So if I look at this and this is CH2CHF. This section is similar to this one. And I can see CH2CH and CF3. This section is this one. Does that make sense? Because if I extend the chain on both sides, I can have this CH2, CF3 and CH. And this is the section that can be produced from CH2 and CH. So again, in this case, the answer will be A. Then you can try again. So you can see here, this is also the red one. And this section is again the blue one. Then this is the blue section. And this is again the red section. Okay. Question number 19. It says the equation for the reaction between zinc and hydrochloric acid is shown. What's the maximum mass in milligrams of zinc needed to react with 50 centimeter cube 1.68 mole dm cube hydrochloric acid? So this means I can change this into moles. So the moles of acid from here will work. If you work them out, you will get the answer as 0.084 moles. Now my equation says 1 mole of zinc will react with 2 moles of hydrochloric acid. So the moles of zinc will be, if I divide this by 2, what do I get? 0.042 moles. I can multiply it by 65.5. What do I get? 0.042. 65.4. This gives me answer. Mass will be equal to 2.7468 grams. Now I need to change this into milligrams. Milligrams means I can multiply this by 1,000. So this is same as 2.7468 times 10 to the power of 3 milligrams. That's my mass. Now which one is similar to this answer? The answer is C. Next question says an equilibrium mixture is prepared in a container of fixed mass and fixed volume. Carbon monoxide, chlorine, this gives you COCl2 and the reaction is exothermic. This means if the temperature goes down, then the forward reaction will be favored. If the temperature goes up, then the backward reaction will be favored. Now let's see what does it say here. So the temperature of this mixture is decreased. So in our case, this is the section that applies to our case. The mixture is allowed to reach a new equilibrium, which is greater for the new equilibrium than the original mixture. So decrease means what? More product and less reactants. Does that make sense? The mole fraction of carbon monoxide is greater. I've got less of this now. So this is wrong, right? It won't go up, it will go down. This should go down. The partial pressure of chlorine, again, it will go down. This is wrong. Why? Because we have less chlorine. The total pressure of the mixture, what will happen to it? Again, it will go down because 2 moles of gas will change into 1 mole of gas. Does that make sense? So you'll have less particles. So if there are less particles, that means there will be less collisions and the pressure will go down. It says the value of the equilibrium constant Kp. You have to recall it depends on temperature, and it is always products over reactants. So in our case, my products have gone up, but my reactants have gone down. Therefore, Kp will go up. So the answer is D. Question number 21 says, in concentrated alkali, propane none reacts with hydroxide ions to form an equilibrium mixture as shown. They've given us the equation, and I can clearly see here what has happened is I've introduced the double bond at this location. So one of the hydrogen has been removed from. It says which curly arrow does not appear in the mechanism of this reaction. This is true. This will appear. Why? Because this hydrogen will give its electrons here, and therefore you'll have the double bond. In this case, this is wrong. Why? Because the electrons from here have now gone to this oxygen, and that's why it has a negative charge. This is wrong. This is correct as well, because both of these electrons will be given to this hydrogen, and therefore it will come out as water molecule. This is true as well, because look, this is shown here. This is correct as well. The only option that's not right is B. Now the next part says the diagram shows the curve produced by adding strong alkali to a weak acid. Which point on the curve represents a solution that can act as a buffer? So what is buffer? Buffer is salt plus acid in this case. Salt plus acid. So when do I have salt plus acid? Here it is all acid. So here it is acid. Here it will be salt plus nothing. Here I'll have salt plus alkali. It is here, it will be salt plus acid. Okay, so it will be, the answer will be B. So that's the only possible option. Next question says, which alcohol could be produced by the reduction of an aldehyde or ketone? Aldehyde will always give you primary alcohol. Ketone will always give you secondary alcohol. Now you have to identify which of these is primary, which of these is secondary, which of these is tertiary. So if I look at the first one, it is propane 1-ol. This means there are 3 carbons. On the first one, you have OH, you have H, you have H. On the second one, you have dimethyl. So it's CH3 and CH3. This is my primary alcohol. So this is possible. It can be produced, but the question says not. When I look at the second option, which is 2-methyl butane 2-ol. Butane means 1, 2, 3, 4. On the second one, I have OH. On the second one, I have carbon as well. What kind of alcohol is this? This is my third degree. This is my primary alcohol. So the moment I see third degree is produced, this is the answer. This one can't be produced. Only primary and secondary can be obtained. Next question, question number 24. It says, which compound does not show stereoisomers? Now, when it comes to stereoisomerism, they are talking about E and Z plus optical. E and Z and optical. So if I look at 1,2-dichloropropene, propene means I've got 1, 2, 3. At this location I have a double bond. On the first one I've got chlorine. The second one I've got chlorine as well. I can have H here. I can have, in this case it will show E and Z because there are 2 chlorines, one on the left side, one on the right side. So I can say E and Z is shown. This is fine. 1,2-dichloropropane. Propane means I've got 1, 2, 3, 4. Here you have chlorine, hydrogens. On the second one you have chlorine as well. I can see here this is my chiral carbon, so it will show optical. for 1,3-dichloropropene. 1, 2, 3. On the first one you have chlorine, the last one you have chlorine, rest are all hydrogens. In this case, I've got chlorine here. This is not going to be there, right? I've got hydrogen here, I've got hydrogen. So again, it will show E and Z is possible in this case as well. Now there's only one option left, which is D. So this is my answer. 2.5 says, which compound can form a polymer without needing another reagent? Can form a polymer without needing another reagent. You've got 2 alcohols, not possible. You've got 2 carboxylic acids, not possible. You've got carboxylic acid and haloalkane, not possible. Here you've got acyl chloride and an alcohol, so ester can be produced. This will change into ester. The answer is C. Next question says, a solution of lead 2 chloride contains 1.08 grams of PbCl2 in 100 centimeter cube of solution. In this solution, the lead 2 chloride ions, or it is fully dissociated to its ions. What's the concentration of chloride ions? So if I look at this whole thing that they have said, it is PbCl2 will change into Pb plus 2Cl1 minus, and it will be 2 plus. So in this case, I've been given 1.08 grams in 100 centimeter cube solution. So 1.08 grams, I can change this into moles, and this will turn out to be in moles 3. One second. If I do 1.08 divided by 278.2, 3.88 times 10 to the power of minus 3 moles. Now these will be twice, so the moles of this will be 2 times 3.88 times 10 to the power of minus 3. That gives me answer as 7.76 times 10 to the power of minus 3 moles. Once I know these, I can use my formula. Moles equals C times V over 1,000. Replace moles with its value, which is 7.76 times 10 to the power of minus 3 equals C times volume is 100 over 1,000. And if you work out, the answer will be D. Next question says, the rate equation for the acid catalyzed reaction between iodine and propanone is given to you. So this means with respect to iodine, it is 0 order. Are you happy? So because it does not appear in the rate equation. Now it says the rate of the reaction was measured for a mixture of iodine, propanone and sulfuric acid at pH of 0.70. The moment I see this pH, this means I can work out the value of H plus ions from here. That will be 10 to the power of minus 0.70. Okay. And if I do that, I'll end up with 0.1996 mole per dm cube. Now it says in a second mixture, the concentration of sulfuric acid was different, but the concentration of iodide and propanone were unchanged. So they are not changing this. So the rate only now depends on the concentration of H plus. Say the new rate of the reaction was quarter of the original. Now I know with respect to H plus, what is it? It is first order. So if the concentration goes down, what will happen? sorry, not the concentration. If the rate goes down, that means the concentration has gone down by the same factor. So what will I do? I'll divide it by, says what's the pH of the second mixture. I'll say the concentration will be 0.1996 divided by 4. And what will I get for this then? 0.1996 divided by 4 gives you 0.05 mole per dm cube. Then you have to do the same thing again. pH equals minus log 10 0.05 1.30. So the answer is B. Next question says a 385 centimeter cube sample of carbon dioxide at 100 kPa and 25 degrees Celsius was mixed with 2.89 times 10 to the power of minus 2 moles of argon. The gas constant is given. What is the mole fraction of carbon dioxide in the mixture? Now they've given us the volume here. We've been given the pressure, we've been given the temperature. We can make use of PV equals nRT. But it will require unit conversion, so you got to be very, very careful. The pressure will be 100 times by 1000, because that's 100 kPa, times by volume is 385. But I can't use in centimeter cube. I'll have to convert it into meters cube, and for that I'll do 10 to the power of minus 6. Just make a note of this. When you go from centimeter cube to meter cube, you will multiply it by 10 to the power of minus 6. Equals n times 8.31 times by 273 add 25. From here, if you solve, you'll end up with a value of n. Now these are the moles of carbon dioxide. These are the moles of argon. So to find out the mole fraction, what will I do? I'll then do n divided by n plus 2.89 times 10 to the power of minus 2 times by, because the total pressure was 100 kPa, I'll have to multiply it by 100. This is the partial mole fraction. Okay, we just need to do work out the mole fraction, so we don't have to do in this work out. So this value will come from here to there and there. Next question says, how many peaks does this compound have in its carbon-13 NMR spectrum? So I can see this and this, they are both in different environments. So I can have 1, 2, 3, 4, 5, and 6, 7, and 8. So the answer is going to be D. Yes, Reach.
So how would you draw this molecule up normally?
This molecule.
Yeah.
What do you mean normally? Like with carbons and hydrogens?
Yeah.
You can't draw it. See, so wherever you see there are two lines are joining. That's your carbon. So I can start with carbon dash sulfur dash carbon dash carbon.
Is there like two? There's the two like cyclo things.
Yes. So if I carry on, it will be dash C double bond C dash C dash C and then double bond. Now you just have to make sure that each carbon has 4 bonds around it. So you can put a hydrogen here, you can put a hydrogen here. You don't have to put any hydrogen, a hydrogen, a hydrogen, a hydrogen, and a hydrogen. Does that make sense?
Yeah, thank you, sir.
Okay. Next one says a student is provided with 50 centimeter cube of 1 mole dm cube of ammonia solution. The student was asked to prepare an ammonia solution with a concentration of 0.050 mole dm cube. What volume of water should the student add? I really like this question, right? Because when I'm preparing solutions for the lab, and when students come in and they do their practical work at the center, I have to make these solutions, and then you have to find out the dilution factor. So in the first case, what I can do is I can work out the moles from here. So if you work out the moles from here, you'll end up with a value which will be 5 times 10 to the power of minus 3 moles. And then you have to use m equals C times V over 1,000. You can work out moles are 5 times 10 to the power of minus 3. C is known, which is 0.05. We don't know the volume that we should have over 1,000. So if you solve it, you'll end up with V being equal to 100. Now you can't say it will be 100 because out of this 100, 5 centimeter cube water is already there. So the answer will now be B. Okay, so I'll do 100, take away 5, which leaves me with 95. So I'll add 95. I'll take 5 centimeter cube and I'll add 95 centimeter cube of deionized water to make my solution. Next question, I really liked it as well. Can you please put star on this question as well? Here it says a solution absorbs light with wavelengths corresponding to red, yellow, and green light. Which ion is most likely to be in solution? Now it says it absorbs. What does this mean? So if it absorbs, then these colors will not be visible. These colors will not be visible. So red is not visible. So the solution will not have any red color because the red color will be absorbed. Yellow, no. Green, no. For this one, Fe2 plus, should it absorb green? It should not absorb green because it is green. For this one, it can't absorb yellow. For this one, it is chromate ions are orange. They are orange. So they go from orange to green when you use them as oxidizing agent. You don't remember that? Come on, you have to. So in this case, I don't see the blue color because it has not been absorbed. It will pass through. So it could be copper ions. The next question says a reaction is exothermic and has a negative entropy change. Exothermic and it also has negative entropy change. So I can recall my equation. Delta G is equal to delta H minus T delta S. And if you remember, we said if delta G is less than 0, then it will be feasible reaction. And it will be classed as feasible reaction. It says the reaction is exothermic. Exothermic means this value is negative. And it has negative entropy. This is negative as well. Now, if the temperature is positive, if you keep increasing the temperature, eventually this value will get positive. It will be positive. Now, this value will always be positive. I can say this section together, always positive. Let's put it this way, because it makes our life more easy. Now, if the temperature has a very big value, what will happen to this section? This will be more positive, this will be less negative. So if you add a negative number to a bigger positive number, when you add them together, the delta G value will become greater than 0. So it says the reaction is always feasible. That is not possible. Because if the temperature is too large, it will not be feasible.
Sir?
Yes?
I don't understand that though, because if delta H is always negative,
yes,
and let's say you have a really big and you're minusing it by a really positive.
yes.
Oh, it's minus.
Yeah, so
Oh.
because this is minus and this is
negative
minus. So
L
when you
minus
multiply
minus.
these two negatives, it become positive, right?
Yeah, I see it.
So if the temperature is very large, then this value will become bigger than the delta H. And then your delta G will become greater than 0. And it will not be feasible. The reaction is feasible above a certain temperature. Above a certain temperature, that's wrong. The reaction is feasible below a certain temperature. That's true. Because the moment the temperature goes above that temperature, this value will become more positive than delta H, and therefore the delta G will now be greater than 0. Okay, so the answer is C. Last question on this paper, and then we finish with this. It says you have got phenylethanone can be prepared by the reaction between ethanol chloride and benzene. In preparation with excess benzene, the mass of ethanol chloride was 5.7 times 10 to the power of minus 2 kilograms. Let's convert this into grams, and it will become 0.057 grams. Okay, 0.057 grams, and I can then convert this into moles. do I have to convert it into moles? Okay, so they've given us the MR here, which is 78.5. So if I work out the MR, I'm just going to do it by reacting masses. Okay, so we are looking at these two. So I'm going to call it A and I'm going to call it B. So I'm going to say A to B. The MR of this is 78.5. So this means if you use 78.5 grams, theoretically, it should produce 120 grams of B. The MR of this is 120 grams. Are we happy? Now, we are not using 78.5 grams. We are only using 0.057 grams. So if I do 0.057 grams, it should produce, look, so you guys are not telling me this is wrong conversion. This is the wrong conversion, right? In this case, it will be 5.7 times 10 to the power of minus 2 times by 1000. And if I do that, it will become 57 grams. Are we happy with that bit? Okay, so it will be 57 grams. So I can say this is my 57 grams. Now, once I've done this as 57 grams, I don't know how much grams of mass this will be produced. Now, if you cross multiply and work out the value of X, you'll work out the value of X will turn out to be, how much will it be? 120 times 57 divided by 78.5. This gives me 87.13 grams. Now the question says the yield is 62%. So I'll do 62 over 100 times by 87.13, and this gives me answer as 54.02 grams. So the answer is B. Okay, so now we are done with this bit.